we are going to learn how to measure the specific heat capacity of a solid using the mixture method. What is heat capacity? First of all, heat capacity is the amount of heat energy required to raise the temperature of a body by 1 degree Celsius or by 1 Kelvin. So heat capacity of a body is the amount or quantity of heat energy required to raise the temperature of the body by 1 Kelvin, or let's say 1 degree Celsius or 1 degree centigrade. The amount of heat energy required to raise the temperature of a body by 1 degree Celsius or by 1 Kelvin is the heat capacity of the body. Now, there's what we call specific heat capacity. Now, the specific heat capacity of a body is the amount of heat energy required to raise the temperature of 1 kilogram of the body by 1 Kelvin. Note the difference. Heat capacity, the amount of heat energy required to raise the temperature of the body, the entire body, by 1 Kelvin, while specific heat capacity is the amount of heat energy required to raise the temperature of 1 kilogram of the body by 1 Kelvin. All right. This is the quantity of heat energy required to raise the temperature of unit mass or 1 kilogram of a body by 1 Kelvin or 1 degree Celsius. So the total amount of heat energy required to raise the temperature of unit mass of the body by 1 degree Celsius or 1 Kelvin is the specific heat capacity of the body. Now, the difference is heat capacity is the quantity of heat required to raise the temperature of the entire body by 1 Kelvin, while specific heat capacity is the quantity of heat required to raise the temperature of 1 unit mass, that's 1 kilogram of the body, by 1 Kelvin. Now we want to look at how to measure the specific heat capacity of a solid using the mixture method. All right, so let's go right in there. So we need an apparatus known as the calorimeter, a well-lagged calorimeter. But before then, we also need the metallic object. Let's call it a small metal ball this time around. And we need a beaker, we need tripod stand, we need Bunsen burner, we need thermometer, and we need stirrer. All right. So the first setup look like this. We're going to have our beaker placed on a tripod stand. All right. We're going to have our source of heat, which could be our Bunsen burner. All right, that is burning. We have our wire gauge. This beaker is filled with water, and you put a thermometer inside, and you put a stirrer. Then the metallic object is going to be inside. So what are you doing here? You are applying heat to raise the temperature of the metallic substance to theta 1. So this is the initial temperature of the metallic object. After the temperature have gone to a specific temperature, which is theta 1, you are going to move this metallic object, quickly move it to a what? To a calorimeter. You move it to a calorimeter that is well lagged, well covered. But inside the calorimeter, we have another thermometer. Inside the calorimeter, we have a stirrer, and then you are moving the solid ball in here. So you are transferring the ball from the beaker, this is the stirrer, theta 1, to the calorimeter. The calorimeter is filled with water. All right. Now, the mass of empty calorimeter will be measured, which will give us m cal. When you pour the water, the mass of the calorimeter with water will be measured. And then when you subtract, you're going to have m water. How do you get the mass of the water? Subtracting the new mass of the calorimeter with water from the initial mass of the calorimeter. So you have mass of the water. The temperature before you transfer the meter into the calorimeter is going to be theta 2. And that is the temperature of the water and the temperature of the calorimeter. Then the temperature, after you quickly transfer the metallic object from this setup to this setup and quickly close it. Keep stirring. At the end of the day, you're going to have one final steady temperature. Let's call it theta F. So we have theta 1. Then we have M. Okay, so I'll put it MS. So that's the mass of the solid. So this is the mass of the solid object. This is initial temperature of the solid. This is the mass of calorimeter. This is the mass of the water. Now this is initial temperature of the calorimeter and water. This is the final temperature of the mixture. All right. Now you're going to have C cal, which is the specific heat capacity of the calorimeter. You're going to have CW, which is specific heat capacity of the water, and CS, which is the specific heat capacity of the solid, which is what we are looking for, measuring the specific heat capacity of a solid. To recap quickly, you have a setup of a beaker that is on a triple stand with a Bunsen burner that supplies heat and a thermometer right here. Inside the water, you put this solid, metallic solid, let's say a copper inside, and heat it up. You measure your initial temperature, which is theta 1. Quickly transfer it into a large calorimeter with water and stir until you have steady temperature. You measure your final temperature, theta 2. Note that you would have measured the initial temperature of the water and the calorimeter, theta 2, and the final temperature of the mixture after stirring, theta F. Other parameters you need to have measured is the mass of the solid that you are putting there. Initial temperature we measured here, the mass of the calorimeter, the mass of the water that is in initial temperature of the water and the calorimeter, final temperature of the mixture after mixing it. Specific heat capacity of the calorimeter will be known, mostly is copper calorimeter. And specific heat capacity of water is also known, 4,200 joule per kilogram per Kelvin. And now we're looking for the specific capacity of the solid. Simple experiment. Now, how do we get the specific capacity of the solid? A simple formula. It is heat gain is equal to heat loss. In an isolated system, we know that total heat gain is also equal to total heat loss. All right. So what is gaining heat? The water and the calorimeter is gaining heat. The copper solid that you're transferring is losing heat. So total heat loss is, using the formula for specific heat capacity, total heat loss is M of the solid, specific capacity of the solid, times change in temperature, which is theta 2 minus theta F. Because the higher temperature is it is losing heat. That's a higher temperature, and it lost its heat to have a final temperature of the mixture. Total heat gain is heat gain by the calorimeter, which is mass of the calorimeter, then specific heat capacity of the calorimeter, times change in temperature, which is theta final minus theta 2. All right, this is theta 1, sorry, plus total heat gain by water, mass of water, then specific capacity of the water, times change in temperature of the water, theta 2 minus theta final. Final temperature minus initial temperature of the system. So to know the specific capacity of the metal is to make this specific capacity of the solid the subject of the formula. And to do that is just to divide through by this ms theta 1 minus theta final, so that this take away this take away this. Then the whole of this will be mass of the solid into initial temperature of the solid minus final temperature of the mixture. So with this formula, we can calculate the specific capacity of a solid using the mixture method, which means that the specific capacity of the solid is equals to this, and this is the formula. All right. This is mass of water and specific capacity of the water. All right. So with this, you are able to determine the specific capacity of a solid. This is a simple experiment that you may be asked to explain in exam, and trust you me, it's very, very simple to explain. What are the few precautions you need to take while carrying out this experiment? First of all, make sure that you stir continuously, in both setup. Stir continuously to ensure that the temperatures is evenly distributed. That's number one. Number two, when transferring this solid from the beaker to the calorimeter, make sure it's done quickly to avoid heat loss or to minimize heat loss by the process of transferring. That's number two. Number three, when transferring, also make sure you shake off any water molecule that may be here so that it will not come and hide with the mass of water here. Shake it off. That's the precaution you are going to be taking. The fourth precaution you are going to be taking is to the fact that you make sure that the calorimeter is well lagged and well covered so that there will be no heat loss, or you minimize heat loss either by conduction or by convection, right? Then another good precaution you are going to take is to ensure that you avoid error due to parallax when making readings on the thermometer. Yes, make sure you avoid error due to parallax. And with some of this, you'll be able to do what? Have this experiment well conducted and get the specific capacity of any type of solid you are looking for, using the mixture method. Thank you. Make sure to subscribe to this channel, and bye-bye. Hasta la vista.